So this is a homework example video of number 13 from your chapter 1-2 homework. You have a few instructions here. The first one is to graph the parent function, list the transformations, and then graph the transformed function. So number 13, first thing I'm going to do is just graph my regular old 2 to the x. I know this is a function that has an asymptote at 0. This is our function where it got really close to 0, but it never touches it. It's in real life, it's like cutting a piece of paper in half and in half and in half, but the paper never disappears. It just gets smaller and smaller. So our graph crosses at 0, 1. So I always like to put my point there just to remember that that's where that's supposed to be. And then when I go to draw my graph, I'm going to let it get really close to 0. And then it's going to grow pretty quickly over on the right side. So that's my parent function. That's all it was asking you to do there. The next part, number 14, says list the transformations. As far as our transformations, we don't have any multiplying going on here. We know our parent function was 2 to the x. So the only thing that are really happening is this minus 3 in the exponent and the plus 1 on the outside. The plus 1 on the outside tells me that this is going to be a vertical shift. And vertical shifts do just what I think they're going to do. This is going to go up 1 with that plus 1 on the outside. The minus 3 up in the exponent with the x, that's the exponential function's way of putting something with the x, so to speak. And it tells us that x's lie rule, where if it's saying minus 3, that's actually going to move it to the right 3. So those are our transformations, up 1, right 3. So when I go to actually graph my transformed function, I'm going to use key features from my parent function to help me do this. The first being the asymptote. The asymptote is at 0, that dotted line is at the line y equals 0, or the horizontal line, which I can't move right 3. It's an infinite line. If I move it right 3, it's still going to be an infinite line, so I won't see that. But I will see if I put the asymptote up 1, then my asymptote will now be at the line y equals 1, not the line y equals 0. Which means that my point that I used as a reference, that y-intercept at 0, 1, will now also be scooted up 1, but not only will it go up 1, it'll also go right for 1, 2, 3, so it'll be right there. So it used to be here, and it moved up 1 and right 3. Then as I go to draw my function, I'm going to approach my asymptote without actually touching it. And I'm going to start here and be really small. Then I'm going to follow that same pattern of increasing after my new point that used to be my y-intercept right here. So that's it. That's number 13 and 14. That's all you had to do. And the full thing looks something like that. We have our parent function and our transform function.